What is this, Lady Ada?
Hey everybody, it's our weekly 7:30 p.m. Eastern Time super party called Show and Tell with me, Lady Ada, Mr. Lady Ada, his special magical pen, and all of you, the viewers and the makers around the world who, in this fabulous new year, 2018, are making and creating some wonderful things, and we'd love to see them. Come on by. We're here every week, the Adafruit channel. But right now, we've got some cool people lined up. Going to call on you in the order we see you, mute your mic until we call on you, then take 2 or 3 minutes to off your project. Get out of here at 7:50. Start off with some Adafruit peeps. Phil B, take it out.
Oh, hello there. I have a Neopixel strip running, you know, good old color swirl thing going on. Seen that a billion times. But this one, I'm working on a new CircuitPython library, kind of inspired by Fast LED, which does all this really nice color palette type stuff and waves and whatnot. Trying to provide some kind of similar functions to Fast LED for CircuitPython. So this is actually running CircuitPython on an M4 board, and nothing real innovative to look at right now. But the hope is that you'll be able to take existing projects and move them into CircuitPython without completely rewriting from scratch. And it's just a small subset, just the palette functions right now, but piece by piece, hoping to get more of that implemented in there. And we'll have a guide for that, probably be live tomorrow. I just need to add a thumbnail thing, and that's it.
Wow.
Okay. Thanks, Phobia.
Everyone needs more Blinky.
I will never get tired of the color swirl.
I'll never get tired.
I was telling Phobia in our weekly meeting, there's a Lexus car, and they just covered it with Neopixels. I'm like, that's the Adafruit Neopixel card. That's fine. This is it. This is Neopixel all the time. All right. No, Pedro.
Hello. Hey, guys. So a couple weeks ago, Phobia had some really cool code and a prototype for this super cool little LED sand. Oh. So he had an idea of coming up with a cool little design for it. And it is this cool little gyroscope?
Gimbal, gyroscope, whatever you want to call it.
Everybody keeps correcting us on it. But it's a cool little 3D printed enclosure to show off the very cool unstableness of this little circuit sandwich that's inside here. Makes it wobble around in unpredictable ways, causing all of the little grains of sand to go all the way everywhere. We have a couple of different enclosures for this.
Mine's a box. I'm the box guy.
So that's the parametric feather box.
Yeah, you could use a feather box too if you have one laying around.
More fun.
You could say it's a miniature version of the virtual reality system that Job was in Lawnmower Man.
There you go.
Not a gyroscope, but he was like in there and he's like, look at me, I'm like shopping in space or something. So that's what you can say.
Yeah, so we got all of the files available on the Learn system as well as the code that Phobia cooked up. And we showed off a bunch of the techniques for modeling all this on 3D Hangouts earlier today, so you can check that out, as well as all of the files and what else did we cover on there? A bunch of other stuff. Check out the show.
It's like a baby mobile toy of the future in like 2035. It's like, here you go, kid.
Totally.
All right.
Thanks, guys.
Next up, JP.
Nice.
Hey, guys. How you doing?
Yay.
Hey, so I'm working on a couple things I wanted to share. One is a little prop for someone contacted us who's doing a cosplay of the wind blown emoji, which go look it up, but it's like Mother Nature blowing, and there's a cloud and there's wind. So I've taken a little CircuitPython, a Circuit Playground Express, and in make code actually, if I put a little, actually I'm going to turn down my light so you can see this. If I put a little puff of material on there, when you blow on it, using the microphone as a sensor.
Ooh.
And then we'll blow on it again, and it will dim back down.
That's nice.
And so that's a little guide that I'm probably just going to...
Simple, but like really cool.
Real simple, but a fun little project. And
the origin of this, we have a friend, and she said, I'm going to cosplay like a character. It's like this emoji. I'm just like, oh, right. Like that's what's going to happen now. So this is going to be remade from someone, maybe their first electronics project. So thank you, JP.
Sure thing. Yeah, it's fun to work on those because it ends up being a kind of exercise in thinking through the logic of what you're trying to do using the little GUI blocks of make code, which I really like. Actually, it's a lot of fun. And then I'm also working on, if you caught my live show last Friday, I'm going to kind of continue the project tomorrow on my live show, and that is the coin acceptor for my Picade. So I'm using our coin acceptor that we have to take quarters and make that work inside of the main emulator. And so I'm building an enclosure there. So I started working on that today. Here's a prototype of one of the side panels that I cut out of a spare Adafruit box that I had laying around, which I like to prototype laser cut stuff on in cardboard. So I'm going to show a little bit about how I built that in CAD, what the sort of techniques are there. There's a couple major techniques for laser cutting. This is an alternative to the sort of finger joints that you see a lot, and this is using little tabs to have captive nuts and screws to hold things together. So I'm going to show that, and I'll be doing a guide for both of these. So the cloud guide, look for that in the next day or so, and then sometime next week for the coin acceptor.
Okay, thank you so much, JP. Next, Blitz City. Welcome back, Blitz City. How are you?
I'm good. How are you?
Blitzing.
Good.
So this week I built a kit. It's an OK Synth by Oscatone. It's an open source analog synthesizer. And you 3D print the enclosure. It has all the CAD files up and everything. And the way you get the black on is that you actually stop the print at a certain layer height, and then you change the filament out to get the multicolor. And so yeah, it has some really cool tone. And it also can do multiple octaves. So yeah, really fun kit.
Neat.
And one mod I definitely want to do is there's space on the board to add in a 1/4 inch output. And so I want to put that in with a switch so that I can use it with effect pedals. So yeah.
Outstanding stuff. If you're around at the end of the show, we might ask you to play us out.
Oh, awesome. Okay.
You ready? Okay. Now, the Coding Pro.
Okay, so I got, as for a Christmas present, I got the AdaBox 02. And I made my robot, and it's actually been helping me charge a battery for my Gem M0 for my project actually today.
Cool.
So,
Robots helping projects.
it's sort of like JP's secret lockbox, but it's different. So what I need is like something magnetic or, yeah, something magnetic, and then I can, okay. So, I have my box, not totally perfected yet. So it locks, see it has a servo, you can't open it.
Mm-hmm.
Then, there's nothing on you can't see anything. But on the back here, if I take my magnetic screwdriver, put it somewhere over here. Why does this always happen?
It's live demos.
Okay.
Magic is hard.
Yeah. Okay, well, it should, it just unlocked on it, but.
Okay, great.
That's cool. So you put it by and then unlocks it.
Yeah.
Yeah.
It's a mystery, so it's not easy.
Yeah, it's very secure.
Yeah.
Okay. Outstanding. Well, it's a box, so you have plenty of room for a show and tell sticker if you want. All right. Thank you so much, Coding Pro.
Thanks, Jennifer.
Okay. Next up, Tony Sherwood. I know you, Tony. How's it going, Tony?
Hey.
What you got going on?
Hey guys, doing good. I am here at my kitchen table, and let me see if I can reverse the camera. Can you guys see that?
Yeah.
So I have made a table for doing D&D. This is my new kitchen table. And it's got a 49-inch 4K television in it underneath some 3/4-inch glass.
That is the right place for television.
Yeah. So this is a solid table. Right now I have a Raspberry Pi 0W in it, but that doesn't have quite enough grunt, so I'm going to get a Asus trinket board to put in it. But it works. We've been playing D&D for about a month now.
So you can lit up the maps and everything. You can do whatever you want on it. And just how do you control it?
I have one of our little keyboard thingies here.
Oh, this is great.
And
Okay.
sometimes if this isn't enough, I'll drag out the real keyboard and mouse. But
Yeah, SSH in and stuff.
This is definitely
to change your table.
the most popular D&D. Like,
Yeah. Can you
everyone comes over to your house.
Can you send a few photos and I'll post it up on the blog?
sure.
It was fantastic. This is like the next gen tabletop. You have to get like Noah and Pedro to make you 3D printed dice and have them like communicate in for other games and stuff.
Well, it's actually really
Yeah.
smart because if it's really cold where he is, he's like, I don't want to haul over to like the DM's house. Everyone
No.
comes over to his house.
Yeah.
I used to play
I,
Talos Atlanta. I don't think anyone's ever heard of Talos Atlanta. Anyways.
The other thing I'm going to do is put a bezel to cover up the area that isn't screen.
Yeah.
And I thought about maybe putting LEDs in there or something. So
Yeah, Neopixels.
Nice
Yeah.
table.
All right. Outstanding. Okay, next up, JMK. How are you doing, JMK?
Awesome. So I've been looking at this older, some VTech Kitty Zoom weird watch thing, and I noticed it's kind of like the tiny screen. It's got a screen there besides the camera, 2 buttons at the side, and I was like, well, this is a good idea of a casing maybe I could use, like a casing like this. So I may 3D print that at the library here in Westport or something soon. And then also I've made a function in Arduino to sleep after 10 seconds until you wake it up using the top left button. So this is the system info application. It just says press to wake, some info about it, no SD and no real-time clocks plugged in. But anyway, after 10 seconds it goes black until click the button at the top and it shows the text again.
Oh, great.
And for some reason, I can't screen share through Vivaldi, this browser mess up. But anyway, I've been working on this and thinking about, and then I remembered this bezel's a little too big to fit the tiny screen, but whatever. And I've been messing a little bit with copper tape and stuff. So yeah.
Awesome.
Yeah, I like how you're doing an enclosure and figuring out. Someone spent a lot of time on that, so you can just like, oh, cool, like this is a good idea. I can make stuff that works with it. Or,
yeah. There's also one thing I want to mention. That on Tiny Screen's website, Tiny Circuits, there's a smartwatch kit, and that used the older model Tiny Screen. I think I was talking about this before, and the first time I showed it. But that had a 3D printed enclosure, except it was bigger because it was made to house that, a real-time clock, I think. Watch, but and the Arduino, because the older Tiny Screen didn't even have a CPU. So I think I might use that design, but do some modifications and make it pretend that I have a bigger screen than I do. I'm gonna like make the bezel a little bit bigger so you can see the glass.
That's cool.
Just because I like pretending I have more screen space than I do. But anyway. Yeah. Also, wait. This is important. GMKOS 1.8 is finished, and it's going up either today or tomorrow. So.
Yay!
Oh, yay!
Congratulations on releasing JMKOS 1.8.
All right. Well, if you want a sticker, email. But also, drop me a note, and I'll do a little blog post about JMKOS on the blog.
Awesome. Yeah.
You got a lot of users.
Wait, would I put that in cool things for the blog, or would I email support at Adafruit?
If you're gonna get a sticker, just say forward this email to Phil with the links, and I'll do a blog post for JMKOS.
Sure.
Have your team contact my team.
Yeah, because we know you're busy. You don't have time to email all day. Just send one email.
You gotta outsource this to your team. Okay. Excellent. All right. Next up, let's see. GB came in. Hello, GB.
Oh, more AU.
So, so far with this computer thing, it's come quite a long ways. Sorry about the lag. Ever since the Intel Meltdown Inspector bug happened, my computer has been hit pretty bad with the patch, so I've been having like almost 45% slowdowns.
Me too.
Oh, man.
That happened to me, and I'm just like, you know what? This isn't great.
Which is unfortunate because you're designing a CPU that could possibly replace your computer, but
it's slowing you down.
Maybe it's on purpose. It's like jealous of the CPU you're designing.
All right.
It is jealous. This is what found Meltdown. This is all to blame. So far, all complete. Last time I was here, there wasn't much, but I've done a lot. I've made a bootstrap loader, the registers, the ROM, well, one of the ROM banks, and a bunch of commands that the system can use up here. So far there's one ROM bank, and this one, all it does is just a no operation. But because of that, that counts as an operation. So yes, I can use this computer. You can watch it run. It's not going to be doing nothing. It's reading a command that tells it to do nothing. So let's run it.
Hurry up and do nothing.
So, and you see, there it goes. First, it'll read from, it'll increment the program counter. Read from RAM, increment it again, and then it'll read from RAM. So then it increments it again, and you could see it doing that up here. It goes so fast it doesn't actually show up because it resets on the same frame that this turns on, because this is the reset line. So you can see your opcodes are coming in here. Oh, no, it's actually, yeah, the opcode is 0. I just forgot it was 0. So yeah, this is the opcode. So nothing with the value section. This is just staying blank because no operation doesn't need the byte. But other commands like adds and subtract had to get all these cables and route them, most of them to the register. But to other things too, like the register has the no, I meant the ALU has registers. This is the register right here. You have your read and write commands. You can only store 1.5 bytes using this. And its total memory capacity is, I think, yeah, it's 112 bytes in total. But I'm working on making a game for this. I'm actually working on making a Pac-Man clone. Let's run on this CPU using a little screen I'm gonna build for this. It's gonna use ROM switching, lots and lots of ROM switching.
Okay.
Outstanding. Okay, well,
yeah.
Keep up the good work.
This is good. This is sweet.
Thanks.
I love watching this expand from a simple ALU into.
Soon one day you'll need to patch your chips.
Sega Genesis computer.
Yeah.
All right.
Yeah.
Okay. Bamjaku?
Howdy.
Hello.
Hey.
Okay, so it was almost a month ago now. Christmas happened, and I got rid of my project. I am going to screen share a video of it, though. It was a tensegrity tower that didn't have the LEDs on it yet.
Right.
Yeah, that's right.
So let's see. Can you guys see the black screen right now?
Yep.
Yeah.
Okay, cool.
Works.
Ooh, that's nice.
So I just programmed a couple, like, it was like right up against the line, obviously, because that's the only way to do projects.
Yeah.
So I just finished up a couple quick animations and then handed it off to my dad. But yeah, it's pretty simple. It's Arduino Micro, I think.
Mm-hmm.
And then yeah, just some LEDs running up all the compression members.
That's cool.
That's nice.
All right, if you want a sticker, we'll send you one. But also, you can drop me into PTA data for since you have a YouTube video. We'll post it up on the blog.
Cool beans.
All right, outstanding. Okay, next, Samuel. Hi, Samuel.
Hey, we can't hear you, Samuel.
Mute your mic.
Okay, try now.
Hear me now?
Yeah, we can hear you. What you got?
I'm working on a project. I know you guys know what 3D printers are.
Yep.
I've been working with there's a very noticeable price difference between T slots and B slot extrusions. These things right here, 1,000 millimeters of T slot extrusion 2020s.
Mm-hmm.
8 of them in total right now for a 3D printer build I'm wanting to do.
Yeah.
The height of my printer is to be 1 meter tall.
Oh,
millimeter lead screw.
Got it. You're breaking up a little bit, so I caught most of it. It sounds like I'm making a giant 3D printer
with some T-slot.
With some T-slot.
Yeah.
Yes.
Okay, we got it. So this is the start. This is the beginning of the project.
Yes. Yes. What I'm going with right now, instead of going with bearings, I'm going to make some bushings of my own. And I decided to think, what plastic should I use and what shape I should use it. I did a little research on like a regular T-slot extrusions, like the bushings for them, but they're like $55 a piece. Right.
Yeah.
Yeah, too expensive.
Yeah. So I decided to make my own DPE, aka milk jugs. And basically, I got some round and I was thinking about going square, but because of the roundness of these things right here, it makes a perfect contacts at all. But the idea is that it's a pretty sturdy bushing with no play.
Okay. Looks great. Come back when you've got your project built.
Huh?
Come back when you've got your 3D printer built.
Oh, okay. Yeah, that's my plan because right now I'm going through material to see what I need to do. And right now I have a really good idea of, and I'm going to make like a CAD models so that I know exactly what I'm doing.
Okay.
Okay, sounds great.
Thank you so much, Samuel. Good luck building a giant 3D printer. Is
That's
cool.
always fun.
Okay, Adam, play us out.
So, hello there. It's been a pretty interesting week. As you can see, I've actually got the instrument on behind me, which is really exciting. So, I've got this thing fired up over the weekend for the first time in a long time. All my vacuum links are taken care of, and I've got something pretty cool in it. So, I'll go ahead and share screens real quick so I can show you what I've got going on in here. So you should recognize this. This is a CCS 811 environmental sensor. I've actually had one of these under my old ISI SDM quite a long time ago, but I've got this new one and I got a new sensor. It's a lot cleaner, so I'll be able to get some pretty good images of it. So I mounted it up to a sample post and then went through the very, very careful process of trying to cut off this little plastic cap here. So I kind of took a little a scalpel around the edge to break it open a bit, and then I was able to use a pair of flush cutters to pull the whole thing apart. So, and you can also see here, I've put this conductive carbon tape all around the outside of this. And that's to create a relatively low impedance path between all the different pins on here. So they don't get any surface charging effects when I'm running the SEM. Because when you're throwing electrons at something like this, you'll physically charge the surface up. And once the surface becomes charged, it repels electrons, and you can no longer see whatever you're trying to look at. While I'm sharing screens, I'll show you some other stuff I'm working on. I got that, what is it, the Flex 9 LEDs that you guys released recently. Is that right?
Yep.
Yeah, they're
weird. I started taking them apart and figured out that the phosphor is on the top layer. So I'm actually able to scratch the phosphor off, and you're able to directly see it's just some blue LEDs underneath that phosphorus coating.
Oh, that makes sense.
So right now I'm working on trying to figure out how do I actually separate those two layers now so I can get to the in between the plastic and whatnot. And we can zoom in here and once again see those little specks of LEDs. Yeah. So my guess is they've just basically randomly dropped a whole bunch of the semiconductor on the material, and some number of it's oriented the correct direction when it lands, and it's able to actually light up. And that's why you've got this really quite speckled effect that you were talking about earlier.
Yeah, that's really cool.
And my power supply is bad, and it says it can do constant voltage. It can't do constant voltage. It's actually, well, this is kind of funny. The bench power supply I had with me was the one that's supposed to be used for a module on the SEM, so I plugged into the SEM and used my SEM to power this LED strip, which I thought was pretty funny.
It is pretty cool.
Neither constant current nor constant voltage or limiting work correctly, so after about 30 seconds, it decided, hey, I don't like this anymore. And I suspect a capacitor kind of gave up inside and current went high and the LEDs died. But that's okay. I cut just a small section off so I wouldn't destroy the whole thing, and I'm going to go ahead and work on dissecting this and getting it in the SEM. But let's go back to the CCS 811 sensor, because we've actually got that inside the chamber right now. We've got the thing running, which happened all of about 5 seconds before show and tell started. So
yes. Time to spare.
Yeah, I know, right? Actually, I was still working on getting the SEM set up during show and tell, but I got it in there at least. So if we look right here, right now we have got the entirety of the chip. So you can see you can see the rectangular outline. Up here, we've got another one of those tin oxide environmental sensors. That's what's responsible for the volatile organic compound, or the CO2 sensing. And then down here, we've actually got a full-on microcontroller, and this thing takes care of reading the analog signals from the tin oxide sensor and also has a thermocouple on board, and sends it out as an I2C signal. So we can zoom into the control circuitry, and I can do a bit of a stage move real quick.
Oh,
and I haven't had time to really go through and identify what the silicon's actually doing in here, so I'm just going to give you an overview of a couple of rather interesting features. I'm fairly certain these are sensing or power related just because of the grid nature of them. Like example, that right there, I'm relatively confident is the thermocouple, and that's on board, and I'll be able to get some analysis tools to really look at the chemical composition and figure that out. But as you can see, I'm getting just some great resolution with this instrument and able to explore some really fun chips. And I wish I had more time to actually learn how this chip works so I could talk about it in a more certain manner. But
first you got to take its picture and understand it, get to know the chip. Then you can learn about the chip.
Yeah. So like this over here is that tin oxide stuff I was talking about earlier. This is very similar to the forgetting the name of the other sensor right now. It's another environmental sensor you guys sent me, but
the BME 680.
Yes.
Yeah.
So it's a very similar chip to that, and you'd expect that because it has some similar functionality. And I found this part kind of interesting. There's a little manufacturer's logo down here.
Oh.
Oh, this is like some Blade Runner stuff. This is cool.
I know, right?
Oh, who is that? It's like the First Order or something. What's going on?
Yeah.
It's rotated, yeah. Oh, it's charging up. That's fun. But no, as you can see, the instrument's working great. I'm having a lot of fun. I'm honestly getting quite a bit better at using it. And I'm actually at this point starting to install some pretty fun modifications on it. So as you can see on the top panel, I've got a whole host of new modules installed, so it's going to give me more advanced imaging capabilities. I've got an entirely new electron detector, which you can also see down here. This is a backscatter detector, and going to be able to do some pretty fun stuff with it now that it's starting to work better.
Like pimp your scanning electron microscope.
Basically, that's what this week was. And I had all of the work I've done this week has been on my streams. So if you watch on the Discord or on my Twitter, I always post when I'm about to go live, and then spend a couple hours messing around with this. And the streams just started to turn more from why isn't everything working, why is there so many vacuum leaks, to actually doing interesting stuff with it. I went back and looked through all my past streams, and like a quarter of them at least are all like fixing high vacuum leaks, fixing high vacuum leaks, fixing high vacuum leaks. Unfortunately, I didn't have to deal with any of that. So
we started asking engineer was like, is this video working? Like there's eventually everything gets going. It's like, okay, cool. Now we can start doing stuff. It just takes a while.
Yeah. And then
well, thank you so much. Someone mentioned in the chat, they said it looks like that logo is a snake scale, a snake on a scale. Now I can't unsee that. So it's
oh no.
That's what it is. It's a little tiny little snake. It
looks like it's SCC. Honestly, it's got like an S on the end or S in the center, and then two C's on the outside, or CCS. Oh, it's CCS.
I think the snake's like, I let myself go over the holidays a little bit. I'm going to weigh myself. I'm going to get back to the snake gym. All right. Okay.
It's probably CCS.
Yeah. Probably.
No, it's CCS. There we go. Okay.
You call it out. You want. That's a snake scale. All right. Let's see. Play us out with some music.
Some okay music.
Yay! Thank you so much. Okay, we'll see everybody next week. Thank you so much for being on the show and tell. Ask an Engineer starts in a couple minutes. Bye, everybody.